All right, class, welcome to part 2 of the 1.2a lesson video. Right now we are on page 39 in the module, and I am going to go ahead and start on number 6, and pretty much I plan to do the even numbers for the rest of the lesson. So let's start with number 6. Okay, so 9 minus 3 times the group of n plus 3 equals 6n. I hope you are very, very comfortable with this now. We've probably discussed this, a number of times in class. You never are allowed to do 9 minus 3 as your first step, right? You always have to distribute here as your first step, and then you can bring down the 9. Okay, so I hope you really are comfortable with that. 9 minus 3 would be the worst mistake because you would start the question off on the wrong foot already. Okay, so let's go ahead and distribute the negative 3. We get negative 3n. Negative 3 times 3 is negative 9. And then you bring that 9 over, and it's a positive 9. This equals 6n. So immediately on our first question, we get a situation where it's kind of interesting, right? The left side, the 9 and the negative 9 will kind of cancel when we combine like terms. And then we get negative 3n is equal to 6n. And you're like, wait a minute. What's going on, right? I'm going to go ahead and add 3n to both sides just to show you that I want to keep the variable on one side and whatever's left over on the other side. And then I end up getting 9n is equal to 0. And really, you could have just stopped earlier, but now I'm going to just divide both sides by 9, and you end up with n is equal to 0, right? And you realize that, yeah, this is going to satisfy because the right side didn't even have a constant. So 6 times 0 is 0. And then if you plug in 0 here, you'll get negative 3 times 3, really. And then that's negative 9, and that cancels with a 9. So it's very, very possible to get your variable to be 0. It's not the most common, but it is possible. Okay, let's keep going. This is just an extra video for you to watch if you do want more clarification on how to solve, right? Ideally, I could tell you to do these problems, try them, but this video will just serve as a reference, okay? So again, you don't always have to distribute, but sometimes it is just easier. You kind of don't want to overthink sometimes, and maybe distributing is the route you want to go. If I see this question style again, maybe I won't distribute, but in this case, I am going to distribute. I'm going to get a 4 minus 4x, and that equals negative 2x. Negative 2 times 1 is negative 2. Okay. So, oh man, this is interesting. The variables are both negative. And remember, my number one strategy has always been to try to keep your variable positive. So I'm actually going to add 4x to both sides. Now, just to recap, class, we are allowed to add whatever we want on one side of the equation as long as we add it to the other side as well. Okay, so that's what's cool about an equation. You could add whatever you want as long as you do it to both sides. That's how you maintain the equal value, right? That's how you maintain the, both expressions are the same. You're adding the same amount to both of them. That's how it's fair, right? This cancels the variable on this side. And the reason why I added 4x is because I wanted to make sure that the variable was still positive. And it is. Negative 2x plus 4x is 2x. 2x minus 2, and that's going to equal a 4. And you could see that this is a two-step equation now, right? Always get rid of the constant first. And again, I'm writing a little bit big. Maybe you could write slightly smaller than I am. And then divide both sides by 2, and you get x is equal to 3, right? training mode. We're just trying our best, always training, always trying to figure out what's the next step. And it's practice so much where it then eventually becomes muscle memory. You know what you're doing and you know exactly why, right? N divided by 2, I'm going to set this equal to n over 1, right? Even though it was set equal to n over 1 is the same thing as n, okay? So it's like, wait a minute. When would a value divided by 2 equal the same value divided by 1? That doesn't really make sense, does it, right? And at this point, again, you can cross multiply here, and you end up with 2n is equal to n. And the funny thing is you could technically subtract both sides by n, and you get n is equal to 0, right? You should have realized that. Hopefully, at one point, it will become obvious for you, but if you wanted me to solve all the way, I can do that. Okay? I want you to actually try 11. 11 is an interesting question. I'll give you, go ahead and pause if you want to pause this video, but 11 is a good question, and let's just do it together right now. So I see a 2a plus 10, and then I see a 2 times the group. So what's cool is I'm actually going to divide the entire thing by 2 right now. I'm not going to distribute. I'm going to use another strategy like we talked about, and I'm going to divide entire equation, right? Entire equation by 2. Okay, so this term, 2a, will be divided, 10 will be divided, and then the 2 in front of the group is the only thing that I have to worry about. So this ends up being a plus 5 is equal to, now since the 2 got divided away, I could really just write 5 minus 3a plus 4a again, right? It doesn't have that term outside of the group anymore because it got divided away. And then I get, negative 3a plus 4a. Well, that's a, right? We have to be very comfortable adding and subtracting negatives. A plus 5 is going to equal 5 plus a. Now, we know that this is true due to the commutative property of addition, but it's basically the same exact situation. It's the same, yeah, you could subtract 5 from both sides. Yeah, you could subtract a from both sides. Some students end up getting 0 equals 0, and they think the answer is 0. But this answer is not exactly 0, right? Even though they're the same exact thing. When you have the same exact expression on both sides with a variable, you have to realize that a could be anything, right? You could plug in 10, and this could be true. You can plug in 9, 20, negative 1,000. Anything will be true as long as you have the same variable on both sides and the same constant. So in this special situation, we have what we call infinitely many solutions, right? Not only can x be 0 technically, or a be 0, you could say anything you want for a. Now, a lot of students like saying that a equals 0 in this case. And even though that's technically correct, it's not the only solution. So that would not be full credit. You would still get some part of it wrong if you wrote a equals 0. Okay? All right, let's try 2 more. Let's try 13 and 15. Okay, so 13, I see decimals. I immediately want to multiply the entire thing by 10, and that's what I'm going to do. I'm going to clear the decimal, and I move every kind of term one placeholder to the right, and I end up getting x plus 30 equals 8x minus 50 minus 6x. Okay, so far so good. Okay, so now I'm going to obviously subtract, simplify your right side of the equation. You get x plus 30 is equal to 2x minus 50. Okay, so now as you are getting more experience with this, again, you should realize I can kind of see what I have to do, right? I have to move this constant to the other side, and then I have to move this variable to the other side, and I end up getting x equals 80 as my final answer, right? You always want the constants to be on one side, and you want the variables to be on the other side. Okay, last question. Let's try 15. So right now I see a divide by 7, and what I want to do is actually I want to uh, multiply the entire equation by 7, right? That would help relieve me from this denominator, and it would make my life a lot easier. So now it's kind of like saying 1/7 times 7n minus 10, right? Do we realize that this is the original problem, right? So if you multiply the original problem by a 7, you get rid of this 1/7. You cancel this 1/7, and you're left with this untouched 7n minus 10. But then obviously you have to multiply these two by 7, right? Because this is equivalent to this. Okay, just a reminder. Okay, so now I get 7n minus 10 on the left side, and then that's set equal to, I'm actually going to do the 7n first, 7n, and then that's equal to 35. And this is also a very, very special situation, right? Like, wait a minute, 7n minus 10 equals 7n plus 35. Does that sound correct, class? Are you telling me that if we both were 7n and you were subtracted by 10 and I added 35, is that possible that we would ever be the same? Right? So you could kind of say, oh, if I subtract 7n from both sides, I get negative 10 is equal to 35. And that's not true. So it's almost like when you have the same variable on both sides of the equation and your constants are not matching, right? If the constants matched, it would be infinitely many. But if the constants don't match, you guessed it, it's no solution. Okay? We'll talk about this more in class for sure. I hope you enjoyed watching these practice problems. This is part 2 of the 1.2a lesson video. And see you all in class. Thanks for watching.